Okay, so we're going to be doing particle motion today. Okay, so in calculus, we talk about the relationships between velocity, acceleration, and position. Okay, so for this problem, it starts off with asking us to find a function that describes the position of a particle with respect to time. Now, they gave us velocity, okay, and they said that position is going to be located at 4 when the time equals 2. Okay, so we need to find our position equation. Well, they gave us velocity. So v of t is 3t squared minus 16t plus 5. Well, x prime of t is v of t. Okay, so x of t is going to be the antiderivative of my velocity. So what gives me a derivative of 3t squared? Well, that's t cubed minus 8t squared plus 5t plus some constant. Okay? Now, they told us that at time equals 2, so I'm going to plug in 2 for t, so we get t cubed minus 8 times t squared plus 5 times 2 plus c. This has to be equal to 4, which means that c itself is 18. So I come back over here, that means my position equation then is this, 5t plus 18. So that is my position equation. Okay? Now, part B. It says that it wants us to determine intervals in which the particle is moving left. Show the analysis that leads to your conclusion. So let's look at part B. Part B, it's talking about the direction of my particle. Well, velocity is speed and direction. So to find the direction, we need to find first where it is 0. Okay? So this is factors as 3t minus 1 and t minus 5 equals 0. Okay? So my zeros, when t is 1/3 and t equals 5, that's when my particle is standing still. Okay? When velocity is 0, we're not moving. Okay? So now I got to figure out what directions it's going. So if I know at 1/3 it's 0 or not moving, and at 5 it's 0 and not moving, well, what is it doing at 0? Well, when I plug in 0 into my velocity, it tells me I have positive velocity. When I plug in 1, I get negative, and when I plug in 6, I get positive. Okay? So those are my directions. Now, I'm going to say that just like in my x and y chart, moving to the right is positive, moving to the left is where it's negative. So the interval that it is moving to the left is from 1/3 to 5. Okay? Part C. Part C says, determine the acceleration of the particle at 1 second, and time equals 1 second. So part C. Well, we know velocity is this. That's what they gave us. We also know that the derivative of velocity is acceleration. So when you take the derivative, you get 6t minus 16. And so the acceleration at time equals 1 is 6 times 1 minus 16, which is negative 10. Now, find the maximum position of the particle on the interval from 0 to 8. Show the analysis that leads to your conclusion. Okay? So I'm actually going to use my velocity. Okay? I'm going to use part B because we've already done most of the work. Because if it's asking us to find maximum values or minimum values of the position, the maximums and minimums of position are the zeros of my velocity. Okay? So to find maximums and minimums, you take the derivative, set it equal to 0, and those are your critical points, and then you do your first derivative test. Well, if we're talking about position, the derivative of position is velocity. So for part D, I'm going to be using this right here. I've already done it. So this 0 could be a maximum or minimum. Since it goes from increasing to decreasing, this is a relative max. Since this one goes from decreasing to increasing, this is a relative min. Okay? So when it's asking us to find the maximum here, so let's look at it. X at 1/3, when we plug in 1/3 into our position equation, we get 18.814815. Okay? But since we're on a closed interval, we also have to check our endpoints. So I have to check my position at 0, and I have to check my position at 8. Okay? So when we plug in 0 into our function, we get 18. And when we plug in 8 into our function, we get 58. So based on what they're asking us, find the maximum position of the particle on the interval from 0 to 8, if we had just used our critical point, we would have said it was this one. But this is our absolute maximum. So you got to remember to check your endpoints.